joining us again virtually. It's an honor to have an international expert for our next session. Please welcome Mr. Chris Mollison, Director Sales International from EDX Wireless, who is connecting with us from United States. Mr. Mollison is a seasoned wireless industry executive with over 25 years of global experience, leading innovations in RF planning and connectivity. At EDX, he focuses on advanced wireless solutions that support digital and autonomous operations, especially in industries like mining. Let us give a big round of applause even across the ocean.
Thank you, everybody. Thank you. And very pleased to be here and honored to be here. And thank you for the opportunity to talk to you today. The name of the company that I represent is EDX Wireless. And we've been in the wireless business for just on 40 years, so 4 decades now. And that's included a lot of work with the mining industry. And today we're going to talk a little bit about just the future of RF, so radio frequency planning in the mining industry. And as the mining industry evolves and embraces technology, how we can integrate that technology. And we'll focus a little bit about the technology, including the integration of drones and how those have helped our customers globally really address the challenges that come with wireless planning. So just a quick introduction. So RF planning in mining, we believe is absolutely critical to ensure reliable communication throughout the mining operations. We'll have a quick look at what that means as an industry. And we know the industry is undergoing a lot of fundamental shifts, as we see from the presentations today. AI and automation is a part of the mining world today. It's no longer that isolated analog operation. It's become completely digital and is data-driven, right? Powered by autonomous vehicles, real-time telemetry, and AI-assisted decision-making. And all of this is really connected through the wireless networks. So how do you get those different technologies to all communicate with each other? It's through a robust wireless connection. And we've seen throughout the industry that, one has to keep in mind that it's never a single wireless technology or solution that really connects everything together. There can be multiple different wireless connectivities, from Wi-Fi to 5G to private networks. So as RF planning evolves, designing networks to ensure seamless connectivity within the mining operations. So effective RF planning is becoming essential for coordinating activities, ensuring safety, and facilitating real-time decision-making. So we've also highlighted just how important it is not only to, have a robust plan for that wireless network, so how all of those different devices, autonomous vehicles, sensors connect, but to also optimize that network. So once you've either built it or even pre-built, you can optimize that wireless network, which leads to enhanced operational efficiency by really ensuring that sort of robust connectivity, right? When those devices, the autonomous vehicles connect and that connection is stable, it is reliable, everything is more efficient. It allows you to respond, improve the overall productivity of the mining operation. So, we have talked about a little bit about the basics, and I will sort of just get into why RF planning plays such a pivotal role in the safety and efficiency of a mining operation. So, if you think of any plan that we put together, the wireless plan for the network and how it connects together and how it operates, if that plan is done correctly, it really eliminates costly guesswork. So if you plan the wireless network from start to finish, it enables you to design the network so that it's predictable, that you set out to get from the wireless network, from the RF network. And this can be integrated with existing and workflows, which ultimately improve the ROI with fewer outages and a safer working environment. And what we found, as I mentioned before, is not one technology is going to suit all applications. So we've seen across many mining industries and other industries that it's usually a hybrid approach where you end up with perhaps different technologies supporting different parts of that mining. And that screenshot there is
Please hold on. There is some network connections error. We're getting back to you.
Hi, everybody. I do apologize. Seems I was disconnected from the meeting there for just a few minutes. I do apologize. Let me just get that set up again and share my screen. So I do apologize. Looks like I was disconnected. Okay, share my screen. Let's get the presentation back up there. Okay. All right, I do apologize. It seemed I was disconnected there. So hopefully everybody can hear me, and we'll continue on the presentation. Just to sort of summarize, I'm not quite sure when we got disconnected, but just to summarize, I will just end just sort of summarizing that in terms of, why this is so important for the mining operation to really plan that network. And it culminates, at the end of just fewer outages for your wireless network and just your whole operation. safer working environments, because communication is always available and reliable, faster deployments, not only of equipment, but just of everything. So it just reduces the overall CapEx and OpEx as you move forward and run your mining operations. So we'll take a quick look in detail, just as an example of what we've implemented and how we've helped some of our customers around open pit mining, and some of the challenges planning a wireless network, an RF network, is faced due to some of the terrain characteristics and the dynamic environments that were encountered in a pit mine. And if you think, one of the biggest challenges always with this is just the terrain itself. So the rugged terrain and the variable terrain of open pit mines, they can really hinder signal transmissions, and this leads to gaps in coverage or communication issues. So it's essential that we understand the terrain and we understand the impact that it's going to have on your connectivity. As I'm facing at the moment, I keep getting some messages, and I do apologize if the audio quality is not good, that my connection is not that stable. So the other factor that we need to consider when you're looking at planning out your wireless technology or strategy for mining operations is how the environment impacts that. And that would be things like weather. So if there's extreme weather, that can have a significant impact on the type of radio you want to deploy. And then obviously vegetation and geological features as well create significant impact, particularly if there's dense vegetation. There'll be specific technologies or frequencies that you'd like to stay away from. And the geological features, obviously, for a pit mine, that they're ever changing. There's hills and valleys, and the pit mine itself continuously changes. So what are some of the issues that we've seen? And I think the biggest issue is just maintaining that consistent communication coverage. So making sure everything within the mine is always covered. You've always got connectivity. And that challenge comes from that ever-changing environment. As the mine is blasted and excavated, that whole topology changes, and that really impacts creating a very dynamic environment for you to be planning with. Okay, we jump into some of the requirements that we really have for doing an in-depth analysis and planning exercise a pit mine. And this really starts with creating a detailed map of the mine. And our customers across the globe in the mining industry have really embraced some very specific technologies to achieve very detailed mapping. And that would come across as LiDAR. So doing the laser scans of the terrain, and that can be done either stationary or mounted on vehicles. But then we've also had them embracing the drone technology for doing that mapping, and that can be done through LiDAR as well. But then there's other technologies as well that the drones can use to actually map the terrain, capturing different features and making it a lot more quicker to do that particular surveys and accurately capture what the terrain model actually looks like. And this is critical, right? So when we're talking about radio frequencies, when we're talking about wireless technologies, what the terrain, obstacles, vegetation, all of those things has is very important for ensuring that we get coverage and connectivity. So if we take a look here, The other aspect that we need to consider when we're planning a wireless network is what type of mobility are we planning for? So is everything stationary, or do we have devices, people, equipment that is mobile? Because again, as we're looking at wireless connectivity and technology, one of the big things to consider, as we know using our cell phones, is when that device is moving, it means the RF environment that it's in continuously changes. And that's when we need to really make sure that the signal quality is at an acceptable level that ensures that that device then is always connected. And where that mobility is going to happen, so where does that mobility or where does that device or object, where is it going to move, plays a critical role in ensuring that it has the correct connectivity, throughput speeds, availability. All of those become critical as we plan how those objects move. The other aspect that we need to consider is how the environment is going to be continuously changing, and the ability to do real-time adaptable coverage designs. So as the systems move, and we've had customers that have had base stations, repeaters, transmitters mounted to vehicles where they can move them very quickly around the mines. And this is extremely important when we're talking about how do we make sure we have a dynamic coverage in our network, and how do we have continuous coverage? So how can we make sure that we really can dynamically change as the mining environment is changing, ensuring continuous communication and operational efficiency throughout the mine. Now we get into some of the more exciting areas of technology. I know we all talk about drones. They're all used. I think they're becoming part of many solutions, and no different when it comes to integrating drones into the radio frequency planning process. And this is really to enhance the data collection and analysis. So drones are capable really of scanning the terrain and creating detailed 3D maps. And maps, as mentioned before, become a real critical part of being able to plan and deploy and operate a really robust and reliable RF network. And that's really achieved by the best maps that we can produce. And it gives us really some detailed insight into how that signal is going to behave. The data collected by drones can then be used. And what's nice here is drones can be deployed very quickly. They collect the data very timelessly. That means that we can use them to adapt the network. So as the network changes, it enables the network planners to make the adjustments to the network as the landscape is changing. So near real time, not real time, but it really enables the very quick adjustment of your network and optimizing your network to ensure that it's meeting the challenges as that comes. So as the drones facilitate the near real-time planning, this allows the teams to respond swiftly to changes in site conditions, and that ensures really uninterrupted communication and operational efficiency of the communication network and the mine in general, right? So as that all integrates together, any interruption that you have in your wireless technology interrupts the mining operations. So it is absolutely critical that. So we'll look at some key use cases that we've seen and we have many customers that have deployed drones to do a number of different use cases very successfully, and we'll just touch on a few of them today, just to give you an idea. And these can be really deployed anywhere throughout the operation. So one of the bigger use cases that they have is using the drones in a pre-deployment. In other words, before you've built a network, or you have a network, or you've even started the mining operation, you can have the drones go and gather data. They can conduct RF scans. In other words, they can go and actually measure what the RF situation is in a particular area. And that can help you gather that data and make some very educated decisions. Wireless technologies, the more and more we use them, the more and more it becomes difficult to deploy something in an area where perhaps there's a lot of interference, or there's different types of environments that may not be suitable for particular types of technology. It also allows us to continuously update the data. So not only can we use it to do scans beforehand, so pre-planning, so before we deploy, but once we've deployed, and as that pit mine starts changing and we're blasting that out and excavating it, the drones can provide weekly terrain updates. And again, that weekly could be any duration, could be monthly, could be weekly, could be daily, depending on the schedule and the need. But I think we've found, just from the mining industry, that around about a weekly update, conducting both RF scans and mapping scans of that mine allows them to really model that environment very quickly and accurately as everything is changing. We can also use the drones to validate what we've done, right? So once we've done a pre-deployment, once we've deployed the network and set the network up, and you have wireless connectivity, you can use the drones to actually validate, to test that network. So they can go in, they can fly the routes, they can go to the locations that we want to make sure we've got reliable coverage. And they can also be used to identify where do we have some blind spots, where can't we connect to devices or to the network. And we can quickly address those areas and plan to rectify those blind spots by either adding additional transmitters, perhaps moving transmitters, tweaking antennas, antenna heights. There's many things to do to address different issues within the network, and your planning tool helps you address those. So although, there's a lot of advantages with drones, there certainly are some disadvantages to drones, and we'll just quickly touch on those, just so we've got a good understanding of what some of the challenges are with drones. And I think, as many of us know, probably the biggest limiting factor with the drones is the limited battery life. And then the payload, so depending on the drone and the drone type, how much you can actually load, so what that can carry, and the heavier the load, the less the time it can fly. So those are some of the restrictions that we find, just in collecting data and being able to deploy those drones quickly. And then the second one that we've really seen across many different countries and industries is there are some, in some areas and in different countries, some regulations that restrict the flights. So, one would need to check what type of restrictions have been imposed on flight plans for drones, and there may be some paperwork that needs to be done to ensure that that drone can fly the routes that one wants to do. And this can have some limiting impacts on being able to fly it in areas that you need to survey, and it may allow or may mean you're not allowed to fly the drones at all in some specific areas, or it can slow down the deployment if you need approval to actually deploy a drone, if you want to deploy those. So now we sort of a little bit about aligning drone data. So once you've collected this data with your drone, you've gone out, you've surveyed, scanned the RF environment, or collected the digital data on the actual terrain itself, so what the terrain looks like. We now need to collect that data. We need to make sure that that data is compatible with the radio frequency planning tool, so the solution that we're using to design the wireless network, that we can actually integrate that data with the planning tool. And what does that mean? So once you integrate your drone data with your RF tools, it means you can take that data and you can upload all of that scanned data, which makes it much easier, one, to gather the data, and then to use it. So it streamlines that process, right, if those two data sources are integrated. And then it also allows you to do real-time analysis and adjustments to the network. So very quickly take the data from the drones, import it into the solution, your RF planning solution, and conduct an analysis immediately on what that means for your coverage plans. We also can embrace and do embrace AI technologies, and predominantly we use these to predict. So to analyze all of the data that we've collected and that the planning tool provides, take that data and do a lot of analysis and predict where we're going to have potential coverage gaps. So where is the signal not good enough to provide us with the connectivity for our wireless devices that we have set? And that would be one of the parameters at the beginning of the design phase, that we would set specific connectivity requirements, and that would be when the network's available, how long it takes to connect, and then that's a continuous connection, always available connection. So this really allows you to be very proactive. It really ensures a robust communication throughout your mining when you embrace having different data sources, combining that with some artificial intelligence to understand where you're going to have issues or coverage gaps in your wireless network. Once you've integrated all this data, you'd want to take that data and you'd want to sync that with all the other operational tools that you have within the mining industry. This allows you to sync with the data, provide real-time windows into RF conditions, into changing RF conditions, and allows the synchronization of the data from the RF planning tool and the drones to sync with site activities, safety issues, and that just really enhances the overall decision-making and operation of the mine. We'll take a quick look at a case study. This one in particular is in Western Australia. It is an open pit mine, and in this study, drone scans were combined with terrain-aware modeling. And what that meant was they deployed the drones, they scanned the environment to understand the changes, what it looked like, and then they did some very detailed RF planning of their wireless network. And this really meant some significant improvements to the actual results that they were getting from their wireless network. And they did this by deploying weekly scans. So the best granularity that they could adopt to do the scanning was weekly scans. And what this allowed them to do was to scan the terrain, understand how that had changed, optimize their RF network, and the optimization could be moving transmitters, moving repeaters, increasing heights, changing direction of directional antennas, or creating or changing the actual equipment for more powerful transmitters. And this really enabled them to have an extreme gain in operational efficiency. And the results were impressive. So for that particular mine, they saw a 30% gain in SINAR. So SINAR is the signal to interference noise ratio. So this is an industry standard metric that one uses to determine how good the signal is that you're receiving from that wireless network. And a 30% gain in SINAR is a pretty significant gain when running a wireless network. They also had 25% fewer link drops. So the links connecting different repeaters and equipment together, they had a 25% reduction in the number of drops that link was showing. So overall, a very effective approach for them to be collecting data, using it in their planning tool to really plan and improve that wireless network that they had. So what are some of the lessons that we've learned working in the mining industry for many years, a number of decades now? I think one of the big ones is a static model. So just doing a single plan or even the guesswork of, we think this will be good enough in terms of wireless coverage, technology, packed networks is just not enough. It really needs to be dynamic. The case studies really highlight that, just relying on a static model is not really efficient. It is inefficient. The RF environment is dynamic. And as these open pits mines continuously change, one needs to continuously adapt and update your wireless network. We really learned that drones and the incorporation of drones into your RF planning process really improves the network, and it really gives you that tool to make it situational aware. So, what's happening on the ground, what is the exact situation at the moment. And this enables a lot quicker responses to changes in the mining environment, and it really enhances the operational efficiency of the mine. It also ensures interoperability between the drone data that you collect and the planning tool that you have is absolutely critical for ensuring that you maximize the benefits from this integrated approach. So when you collect the data from the drones, it must be integrated into the planning tool that you have. And that allows you to really design and run and operate a very robust, reliable wireless network. So in conclusion, and I know we did a lot of content there on the slides, and we'll absolutely make these available. So in conclusion, I think EDX Wireless has been doing this for many years, and we really like to think of this as the crystal ball for your wireless communication network strategy. So Signal Probe, that is our flagship product for wireless planning, and it really enables you to test, predict, and optimize your network before you deploy it, but also then adapt as the needs of the mine evolve. And this ensures that you're always designing with purpose, right? There's not guesswork as you're making those decisions to deploy expensive technology, and you end up running a really robust, reliable wireless network and mining operation. So for us, EDX is that crystal ball. So it allows you to look into the future, you can see what that coverage is going to be, and you can make it operate in a manner that really allows you to capitalize on the investment that you've made in the wireless network. So that would be pretty much it from me on the information and presentation. Maybe just a quick couple of closing notes. I think we've had quite a few different mining operations work with us, and I think they've deployed some very different use cases around drone integration, around the planning tool, and it really is something that we'd be happy to discuss with you. That would be from minings in the USA, South America, Australia, all around the world, Brazil, where we've really had the mining operations deploy drones, deploy Wi-Fi, LTE hybrid networks. We've had them doing, analysis on flying drones over deep copper mine pits, aluminium mine pits, using LiDAR to scan the data, to scan those maps. We've had them, just using the drones to do coverage validation based on what they've planned out in the planning tool. How has that really effectively been deployed and operating? So thank you very much. I hope this was interesting, and I'd be happy to take any questions.
Thank you, Mr. Mollison, for that illuminating talk. Your session brought out how RF planning is no longer just about coverage. It's about enabling smarter, safer, and more autonomous mining operations. We truly appreciate the global perspective you brought to our discussions today. Ladies and gentlemen, please give a big round of applause for Mr. Mollison. This brings us to the closure of this technical session of the afternoon. We sincerely thank all our speakers, both present here and those who joined us virtually, for their valuable insights. Today's session have not only reinforced the importance of digital transformation, but also showcased the tools, strategies, and mindset required to lead this journey. Before we move on, let us take a moment to express our sincere appreciation to the distinguished speakers. As a token of our respect and gratitude, may I request Shri Jagdish Orara Sir, Director Projects and Technical, to kindly come forward and felicitate our speakers. To begin with, I invite Shri Abhijit Kulkarni and Mr. Vilayak Bupul to please come up on the stage for the felicitation. Okay, I request Mr. Govind Korekar, Mr. Pankaj Kumar, Mr. Pratik Goel, he was joined virtually, so Mr. Sanjay Sairon, all to come on the stage to accept the felicitation. Ladies and gentlemen, please join me in giving a warm round of applause to all our speakers for their contribution and for helping us decode the real world value of Industry 4.0.